In this video, I'm going to solve a question which says that if we have an advection equation and the numerical flux is given over here, then you need to find a numerical method that can solve equation 1. So it means that if we are given this flux, this is the flux, then you need to find another flux yourself. For that, you need to do, you put, you replace j with j minus 1, then here again j minus 1, and so on. Put everywhere where you see j, put there j is equal to j minus 1. So replace with j minus 1. So you can see that from this flux, from the given flux, we can construct another flux as well. Since we needed these flux in the question, this is our flux f of q is equal to uq. U can be a constant, it is a constant. So this is our physical flux. This is our numerical flux. If you are given any flux at j plus 1/2, or then you have to construct j minus 1/2 yourself, then put all these values in the numerical method. This is the general numerical method for advection equation only. Now what we do, we replace the flux values with uq j plus 1/2, which is the flux given over here, and for j minus 1/2 flux we have j minus 1/2. Remember that we need to put n over here, since there is n over here. Put all these values into our formula, equation 4. So we simply inserted the fluxes, all the fluxes, only two fluxes over here. This is fj plus 1/2 over fn j plus 1/2. This is the second one, is fn j minus 1/2. Now the only thing is left, we just need to solve that. So we simply multiply these two terms, and then we also multiply, for example, these terms. So you can see that there's some term which will be cancelled out. You can pause the video and solve it yourself. So after that, after cancellation, or maybe some simplification, we take a common u square. This is u square delta t by 2 delta x, which is taken as a common, and from here we have this term qnj plus 1/2 over here. Then we have, maybe there are no term that will be cancelled out. These two terms will be added together. So when you add these two terms, u square delta t 2 delta x q and j plus u delta t by 2 delta x q and j, since it is half, so it becomes full, u square delta t by delta x q and j, right? So from here we have this term, and after when we take a common, since it was single one, so we have 2 over here, 2q and j. And after that, what we have, for example, here you can take u as a common since it is a constant. Maybe I can solve it for you. Over here, it becomes q n plus 1j is equal to q n j minus u is a constant by 2 delta x. And then we have, for example, q n j plus 1. Remember that if it is q, then it should also, all these values will be q n j as well, since your variable is q n plus 1 j, and same goes to this value q n plus 1 j q. So this also becomes q n 1 j, so on, something like that. Okay, we have to replace it. For consistency, I am replacing all these values with small q. So this remains the same, right? So when we take a common, we get plus q n j minus 1 plus, then we have u square delta t square by 2 delta x square q n j plus 1. It should be minus, there should be a minus, and this should be plus, minus 2q n j plus q n j minus 1, and there should be a plus as well. So what we have this is a very famous number which is called coherent number. So it becomes c square, and this is also a coherent number which is c. So that's what is required over here. The only thing that we need to do is to raise this capital Q, and it becomes q n j. So this is our numerical method. In fact, this method is called Lex-Wendorf method. Lex-Wendorf method. Thank you for watching.